Evaluate limits of rational functions at infinity. Alright, so first we need to discuss limits at infinity of rational functions. Evaluate limits of rational functions at infinity. So, limits at infinity of rational function is what we're going to be talking about in this video. So let's dive into our first example. For our first example, we're being asked to evaluate the limit as x approaches infinity of 5x squared plus 8x minus 3 all over 4x squared plus 3. So now the question is, how do we go about evaluating this limit? Well, if we look at this rational expression, it's really a polynomial in the numerator and a polynomial in the denominator. So if we apply what we know about evaluating limits at infinity of polynomials, we should be able to use that here for evaluating limits of rational functions. So let's go ahead and do that. So the first step when we evaluated limits of polynomials at infinity was to find the variable at the highest degree. So the variable at the highest degree in the numerator is x squared, and the variable at the highest degree in the denominator also happens to be x squared. Alright, from here now we can factor out the x squared from the numerator and the x squared from the denominator, leaving us with the limit as x approaches infinity of x squared times 5 plus 8 over x minus 3 over x squared. And that's all going to be over x squared times 4 plus 3 over x squared. Alright, so now that we have factored out the highest degree variable in the numerator and the highest degree variable in the denominator, hopefully we can see that they are the same, which means we have a common factor here and we can cancel those out. So from here we're going to be left with the limit as x approaches infinity of 5 plus 8 over x minus 3 over x squared, and that's all going to be over 4 plus 3 over x squared. And from here we can apply the limit to every single term. So let's go ahead and write that obnoxious step, but necessary, out. So we're going to have the limit as x approaches infinity of 5 plus the limit as x approaches infinity of 8 over x minus the limit as x approaches infinity of negative 3, not negative 3, that's the subtraction. X approaches infinity of 3 over x squared, and that's all going to be over the limit as x approaches infinity of 4 plus the limit as x approaches infinity of 3 over x squared. Alright, from here we know that the limit as x approaches infinity of a number over a variable is going to be 0. So this will be 0, this will be 0, and this will be 0. And that's going to leave us with the limit as x approaches infinity of 5 over the limit as x approaches infinity of 4. And we know the limit of a constant is that constant, so we're going to be left with the final answer of 5/4. So therefore, the limit as x approaches infinity of the quantity 5x squared plus 8x minus 3 all over 4x squared plus 3 equals 5/4. Alright, so let's take a look at another one. So here we have the limit as x approaches infinity of 4x cubed plus 5 over negative 6x squared minus 7x. And we're going to do the same thing here as we did in the last one. We're going to first look at the numerator, or we're first going to look at the polynomial in the numerator, and we're going to identify the variable with the highest degree, which in the numerator is x cubed. Then moving on to the polynomial in the denominator, we'll do the same thing, and we see the variable with the highest degree here is x squared. Now we're going to factor both those items out of the numerator and or the denominator. So that's going to leave us with the limit as x approaches infinity of x cubed times the quantity 4 plus 5 over x cubed all over x squared times negative 6 minus 7 over x. Alright, let's see, from here we can see that we have x cubed over x squared. So with that we can simplify that expression. So the x squared in the numerator will cancel out with the x squared in the denominator, And that is going to leave us with the limit as x approaches infinity of x times 4 plus 5 over x cubed over negative 6 minus 7 over x. And now we can apply the limit to everything. So let's see, we're going to have the limit as x approaches infinity of x times the limit as x approaches infinity of 4 plus the limit as x approaches infinity of 5 over x cubed over the limit as x approaches infinity of negative 6 minus the limit as x approaches infinity of 7 over x. All right, let's see. We have a limit of a number over an x, so that will be 0. We have a second one, so that'll be 0. And this is going to leave us with the limit as x approaches 0 of x times the limit as x approaches infinity of 4 over the limit as x approaches infinity of negative 6. Now we can go ahead and evaluate these. The limit as x approaches infinity of x, we said, is infinity, times, and the limit of a constant is a constant, so we'll have 4 over negative 6. Now, 6 times infinity is still going to be infinity. However, it's not infinity times 4/6, it's 4. Let's try this again. Infinity times 4/6 would still be infinity, but we don't have 4/6, we have a negative there. So infinity times negative 4/6 is going to end up being negative infinity. Which means the limit as x approaches infinity of 4x cubed plus 5 all over negative 6x squared minus 7x is negative infinity. All right, I want to take a look at our last example in this video. Here we're going to evaluate the limit as x approaches negative infinity of 2x cubed minus x squared plus 8 all over negative 5x to the fourth plus 7. All right, so like the previous ones, we're going to identify the variable with the highest degree in the numerator and the variable with the highest degree in the denominator. We're going to factor out both those variables, leaving us with the limit as x approaches negative infinity. The numerator is going to be x cubed times 2 minus 1 over x plus 8 over x cubed. And then that's all over x to the fourth times negative 5 plus 7 over x to the fourth. And let's see, we have an x cubed on the top and x to the fourth on the bottom, so we can simplify that out. So that's going to give us the limit as x approaches negative infinity of 1 over x times 2 minus 1 over x plus 8 over x cubed all over negative 5 plus 7 over x to the fourth. All right, now we can limify everything, so let's go ahead and make everything a limit. So we're going to have the limit as x approaches negative infinity of 1 over x times the limit as x approaches negative infinity of 2 plus the limit as x approaches negative infinity of 1 over x. And that shouldn't be a plus, that should be a minus. Let me come in and correct that. This should be a minus sign. And then plus the limit as x approaches negative infinity of 8 over x cubed. That's all going to be over the limit as x approaches negative infinity of negative 5 plus the limit as x approaches negative infinity of 7 over x to the fourth. All right, so here we go. Anything with a number over x, that limit will be 0. So 0, 0, 0, 0. So this is going to leave us with 0 times the limit as x approaches negative infinity of 2 over the limit as x approaches negative infinity of 5. And now we can evaluate our final two limits, and we know the limits of a constant are the constant, so it's going to be 0 times 2 over negative 5. But we know that 0 times anything is 0, so therefore this limit, the limit as x approaches negative infinity of 2x cubed minus x squared plus 8 all over negative 5x to the fourth plus 7 is 0. All right, folks, that is it. That is evaluating limits at infinity of rational functions.